My dear students, welcome back to our channel. In this video, I will be explaining the Bachelor of Commerce 6th semester subject Multimedia Systems as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 2, the important short question is: what is a digital image? A digital image is a picture made up of tiny dots called pixels. Each pixel has a color, and when millions of these pixels are arranged in rows and columns, they form an image on a screen. You see digital images every day on your phone, computer, social media, or WhatsApp profile picture. Example: when you click a photo using your smartphone, it becomes a digital image. That image is stored as a file, like .jpg or .png, in your gallery. There are two main types. 1. Bitmap, raster, made of pixels, used in photos. 2. Vector, made of shapes and lines, used in logos. Easy way to remember. Digital image is equal to dots, pixels, plus display is equal to photo on screen. So, a digital image is just a smart way of turning real-world pictures into data that computers and phones can understand and show. Next important short question is: 2. What is video digitalization? Video digitalization means converting a video from its original, analog, form into a digital format so that computers and smartphones can store, play, and edit it easily. In the old days, videos were stored on tapes or film rolls, like in VCRs. Digitalization changes that into formats like .mp4, .avi, or .mov, which can be stored in pen drives, phones, or online. Example: when an old wedding video from a tape is converted and saved as an MP4 file on your phone, that's video digitalization. Why it's useful? Easier to store and share. Better editing. Plays on many devices. Can be compressed to save space. Easy way to remember. Digital video is equal to old video plus computer magic. So, video digitalization helps us preserve old memories and use them with today's digital technology. Next important short question is: 3. What is animation? Animation is a method where many images or drawings are shown one after another quickly to make them look like they are moving. It's just like a flip book. When you flip pages fast, the pictures seem to move. That's animation. Example: cartoons like Chhota Bheem, Doraemon, or Tom and Jerry are made using animation. Even animated stickers in WhatsApp are small animations. Types of animation: 1. 2D animation, flat drawings, like old cartoons. 2. 3D animation, real-looking characters, like in movies such as Toy Story or Bahubali VFX scenes. 3. Stop motion, moving real objects little by little and taking pictures. Easy way to remember. Animation is equal to art plus motion. So, animation is all about bringing drawings or objects to life by making them move, used in films, games, ads, and even education videos. Next Unit 2. Long questions. First important long question is: explain about analysis and recognition of digital image. In simple words, digital image analysis means studying a digital image to understand what's inside it, like colors, shapes, patterns, or objects. Image recognition goes one step ahead. It identifies what those objects actually are. Think of it like this. Analysis: what features are in the image? Recognition: what is this image showing exactly? Example: when you use Face Unlock on your phone, The system analyzes your face like the distance between your eyes, shape of your nose, etc. Then it recognizes you and unlocks the phone. Where it's used. Social media, tagging friends in photos, Facebook, Instagram. Google Photos, finding all photos of a specific person. Medical imaging, doctors use it to find diseases in X-rays or MRIs. Security, face recognition at airports or phones. Self-driving cars, to recognize roads, traffic signals, and people. How it works, simple steps. 1. Input image, a photo is taken or uploaded. 2. Pre-processing, the image is cleaned, removing noise or blur. 3. Feature extraction, important details like edges, shapes, or colors are picked out. 4. Comparison recognition, the system matches features with stored data to recognize the object. Easy way to remember. Analysis is equal to look at features. Recognition is equal to know the object. It's just like how our brain works. You see something, like a mango, you observe color and shape, you recognize it's a mango. In short, analysis and recognition of digital images is all about teaching computers how to see and understand images just like humans do, and it is used widely in today's digital world. Next important long question is to explain in detail about video representation. Video representation means how a video is stored and shown using digital data, zeros and ones. A video is not just one big file, it's actually a collection of images, called frames, shown quickly one after another to create the effect of motion. How it works? A video is made of frames per second, FPS. For example, a video with 30 FPS shows 30 images every second. Each frame is a digital image, and these images are played one after the other very fast. That's what creates motion on the screen. Example. Think of a YouTube video. When you watch it, it's made of many frames, images. Each frame is shown one after the other. Sound is played along with it. The video format, like .mp4, .avi, decides how the video is stored and played. Components of video representation. 1. Frames, individual images. 2. Resolution, size of the video, like 720p 1080p. 3. Frame rate, frames per second, FPS. 4. Compression, to reduce file size, like in WhatsApp videos. 5. Color depth, number of colors used per pixel. Types of video formats. MP4 most common, used on phones and YouTube. AVI used in Windows. MOV used by Apple devices. Easy way to remember. Video is equal to fast photos plus sound. Like a flip book, when you flip pages quickly, the drawings move. Why it's important? Helps in video editing, streaming, and storage. Used in movies, games, online classes, CCTV, and social media. In simple terms, video representation is the digital way of showing motion using images and storing it in formats that can be easily played, shared, or edited on devices. Next important long question is 3. Discuss in detail about video transmission. Video transmission means sending video data from one device to another through a network, like the internet or mobile network, so that it can be watched in real time or later. It's just like sending a letter, but instead of words on paper, you are sending video data. Example. When you watch a YouTube video or attend an online class on Zoom, the video is being transmitted from a server, YouTube or Zoom, to your phone or laptop over the internet. How video transmission works. 1. Video is captured using a camera. 2. It is compressed to reduce file size using formats like MP4. 3. Then it is sent over a network, Wi-Fi, mobile data, etc. 4. On the other side, it is decoded and played on your screen. Types of video transmission. 1. Streaming, live or on demand. Example, watching a cricket match live on Hotstar. Video is transmitted and played at the same time. 2. Download and play. Example, downloading a movie on Netflix and watching later. Full video is first saved, then played. Key terms. Bandwidth. How much data can be sent in 1 second? Higher is better for video. Buffering. Delay caused when video can't load fast enough. Latency. Time delay between sending and receiving the video. Easy way to remember. Video transmission is equal to sending videos through internet highways. Just like traffic on roads, video data travels through digital roads, networks, to reach your device. Uses. Online classes. Video calls, Zoom, Google Meet. Live streaming, YouTube, Hotstar. CCTV and surveillance. In simple words, video transmission helps us watch, share, and communicate through video in real time, making life more connected and convenient. Next important long question is 4. Explain basic concepts of animation. Animation is the process of making images move. It is done by showing a series of pictures one after the other, very fast. When these pictures are shown quickly, our eyes think the image is moving. This is called animation. It's just like a flip book. When you flip the pages quickly, the drawings look like they are moving. Example. Cartoons like Chhota Bheem or Motu Patlu are made using animation. Even WhatsApp GIFs and stickers are small animations. Basic concepts of animation. 1. Frames. A frame is one single image. Many frames together create animation. Example, 24 frames per second, FPS, means 24 pictures are shown every second. 2. Timing. Timing means how fast or slow the animation moves. Slow timing is equal to smooth, slow motion. Fast timing is equal to quick, fast action. 3. Keyframes. These are the main points of action. Example, a ball at the top before it falls is a keyframe. 4. Tweening, in-betweening. Filling the gap between keyframes to make the movement look smooth. Done by the software in modern animation. 5. Path of motion. The direction in which the object moves. Example, a car moving from left to right on the screen. 6. Looping. Repeating the animation again and again. Example, a walking cycle that keeps playing. Easy way to remember. Animation is equal to fast pictures plus timing plus movement. It's like magic made from many pictures and a little motion. Where animation is used. Movies and cartoons. Video games. Mobile apps. Advertisements. Educational videos. In simple words, animation is the art of making pictures move. It brings life to drawings, making learning, entertainment, and communication more fun and creative. Next important long question is 5. Explain about computer animation languages. Computer animation languages are special programming languages or tools used to create animation using a computer. These languages help in designing, controlling, and displaying animated objects on the screen. In simple words, just like we use English or Hindi to talk, computers use these animation languages to create moving pictures or scenes. Example. When you watch an animated movie or play a video game, all the movement you see is created using animation languages and tools. Common computer animation languages. 1. HTML5 plus CSS plus JavaScript. Used for simple web animations. Example, a button moving or glowing on a website. 2. Flash, ActionScript. Used in older animations and online games. Example, old cartoon games and websites. 3. OpenGL. A powerful tool used in 2D and 3D animations. Example, 3D graphics in games. 4. Maya Embedded Language, MEL. Used in Autodesk Maya, a 3D animation software. Example, creating movie-level animation like in Bahubali or Avatar. 5. Blender Python. Used in Blender software, free animation tool. Great for creating 3D animated films and effects. Easy way to remember. Animation languages is equal to tools to talk to the computer for creating movement. You give instructions, and the computer creates motion using those commands. Why are they important? Help create professional-level animation. Used in movies, games, websites, and mobile apps. Allow precise control over movement, timing, and effects. Where they are used. Film industry, Bollywood and Hollywood animation. Gaming industry, like PUBG, BGMI. Web design, animated buttons, menus. Education, animated e-learning apps. In simple words, computer animation languages are the tools and codes that help designers and programmers create smooth, creative animations with the help of computers. Next important long question is 6. What is animation control transmission? How is it done? Animation control transmission means sending animated content from one place to another, like from a server to your device, while controlling how the animation plays, stops, or pauses. It's not just about sending the video or animation, but also controlling its behavior remotely. For example, when you watch an animation online, you can pause, play, rewind, or fast forward. This control is part of animation control transmission. How is it done? 1. Animation data is prepared. The animation is created and saved in a digital format like GIF, MP4, or a special animation file. 2. Compression. To send it easily, the animation is compressed, made smaller, without losing much quality. 3. Sending data over network. The animation file or stream is sent over the internet or a network to the user's device. 4. Control signals. Along with the animation, control signals are sent or received. These signals tell the animation to play, pause, stop, change speed, jump to a certain frame. 5. User interaction. When you click buttons like play, pause on YouTube or a game, your device sends control commands back to the server or software controlling the animation. Example. When you watch a cartoon video on YouTube or an animation in an online learning app, you can control the video. The animation control transmission makes this possible. Easy way to remember. Animation control transmission is equal to sending animation plus remote control. It's just like watching a puppet show and using a remote to move the puppets. Why is it important? Makes animations interactive. Helps in online gaming, e-learning, and video streaming. Saves bandwidth by controlling playback. In short, animation control transmission lets us send animations and control how they play from anywhere, making digital videos and games smooth and user-friendly.